In this video, I sort of plan to write down few of the common Laplace transformation. I know we can always look up the table, but some of them it's good if we memorize some of them. So these are the more common ones. So if the function is ft and fs, of course 1 becomes 1 over s, then t becomes 1 over s square, and in general t to the power n, when n is 1 2 3 positive integer, it becomes factorial of n over s n plus 1. So for instance, if it is t cube, it will become factorial 3, fs of course becomes factorial 3 over s to the power 4, like that. Then exponential e to the power at becomes 1 over s minus a. So this one is positive, so that comes as a subtraction. Then again here I'm moving to the next page. So sine at becomes s square plus a square and a. Similarly, cosine of at becomes same thing, s square plus a square, but in the numerator it is s. Sine hyperbolic at, if we say hyperbolic, that becomes similar but negative, but this becomes negative, so this and a. So instead of here being it's positive when it's just sine at, hyperbolic becomes negative. And for cos hyperbolic, I'm not writing, maybe I will write here ft and fs here. So cos hyperbolic ft, say at becomes s square minus a square, and here it is s. There is another one, e to the power at times sine of at. This is, we encounter such such product often. So when we Laplace transform this one, it becomes, so it's kind of this one and this one together. So let's say this is bt, not both of them are same. So e to the power at is sine of bt, so that will be s minus a square plus b square and then b. Similarly, e to the power at, and if it is cos bt, sorry, then it will become s minus a square plus b square, and here it is s. Similarly, if it were hyperbolic, e to the power at is sine hyperbolic at, and here it is fs. So that would be very much like this one and this one together. So basically it's the same as this one, but s minus a square and whole square and minus here because it's hyperbolic, and then it is b here. Similarly, cos hyperbolic, I hope I am writing all of them correctly. Oh, this will be bt, but just double check. But what I'm trying to say is it's worth memorizing these ones, the more common ones, s minus a minus b square and s. And of course dy over dt becomes, or if we say y prime, it becomes s fs and minus f0. So that's the initial condition. So initial condition differential equation becomes like an algebraic equation, which is very useful. We can use Laplace transformation to solve differential equation because the differential equation turns into an algebraic equation. So we just use standard algebraic procedure to solve different, and then finally we do inverse Laplace transformation to get the original time domain solution. So y double prime becomes s square fs, similar, sorry, s square and then times f of s. So yeah, these are more common ones which it's worth it to memorize, but we can always look up the tables. So yeah, I will do one of inverse Laplace transformation problem later on in another video. And if we the other we will see when we will solve inverse Laplace transformation problems, we will see that is how it's important or how it's convenient to memorize these common ones, because we don't have to, we will be sort of at a loss what will be the inverse one, because once we simplify an expression, a Laplace transformed expression, we will sort of, when we want to find the inverse Laplace transformation, it's easier if we can tell what are the familiar ones. So yeah, anyway, that's it for now.